This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and we have a new partner. Many thanks to Hannover Messe. We are already looking forward to April and our AI event at the fair. So we start into February. I take a brief look at the topics for this month. We start today with John from Econo in Sweden. Next week, we talk to an ex-Audi employee who wants to bring reinforcement learning into production. ABB and Markus Borg from Code Scene follow at the end of the month. As announced, we start today with John. A special thanks goes out to Lamin from Infineon, episode 163. He gave us a hint to talk to John. John's promise, machine learning on the edge. Okay, we already heard about that. Using our SDK, you can rapidly develop and deploy self-learning, predictive, and personalized smart features to your IoT products. He explains how he does it and what his customers, Volvo or Siemens, are doing with it in the podcast. So enjoy listening and greetings to Peter, to Thailand. Enjoy your holidays. And my guest is John Linden from Econo AI, a Swedish-based company. Hello, John. How are you?
Hi, good morning. I'm good.
Please introduce yourself and your company in a few sentences.
Sure. So, as you said, John Linden, CEO, co-founder of Econo Solutions, a Swedish-based edge machine learning software company. I have a background as a serial entrepreneur. I spent a significant number of years in the telecom space before starting Econo. And for the last 4 or 5 years in that space, we saw that everyone was talking about IoT and what's going to happen when things get connected and constantly streaming data. And that was the foundation when I met my co-founder, our CTO, Rickard Koenig, who had been leading research on predictive modeling, so machine learning, and found a way to actually run machine learning on board connected devices, which is a way of approaching that challenge of everything being connected.
Our last guest from Infineon gave us the advice to do an interview with you.
Yeah.
Do you know why he gave us this advice? Do you have a special approach on machine learning?
We do, and we work with Infineon, and for natural reasons, since we are an all-software solution, and of course you need a host for this, which is normally a standard processor. And there are two things. Our unique approach is based on the fact that we found early on that traditional machine learning is all about collecting data from thousands of devices and look for common denominators. But that is pretty rare. I mean, our very first customer,
especially in industrial use cases.
Absolutely.
Yeah.
I mean, the application, where they're being used, the environment, the surrounding climate, all these different things are different from machine to machine. And then learning generic insights is not very useful. So we flip things around and learn individually by actually doing machine learning out on the device. So we learn individually per unit, and we can do this even on very constrained processors down to small MCUs like a Cortex M0 Plus.
So you learn on one machine, but you can't compare the machines then.
Well, you can. And the thing is, you always do your homework before you do the implementation. So you generate a machine learning model, which is based on the collected data, where you figure out things like what are the input values, what's the frequency of those input values, what is the target value that we're trying to predict, what's the prediction horizon. You set up pipelining like sliding averages and lags and so forth. You generate a model that is trained on that. And there's a generic model that you apply, and then you can start training it individually at the edge, meaning that you adjust it to those local conditions, which actually makes a big difference, because that way, without telling the machine learning model what deviates for that specific, for example, the climate, the temperature, the altitude, whatever it might be, that is different. You don't have to tell the machine learning models. That is automatically incorporated as it learns in operations. And then you can train it and you can do inference on the high-frequency sensor data that's being generated on the device rather than the blunt averages, meaning second average or minute average that are typically sent to the cloud. And you do this without any manual intervention, which improves the whole data integrity since you can send more anonymized insights to the cloud rather than sending all the sensitive raw data.
That sounds to me like a federated learning approach.
Absolutely. As an extension, based on the fact that we can do individual learning, we can do federated learning where you do aggregated learning from many. But the benefit is that instead of sending all this huge data to the cloud and then processing it, you actually do the learning in step one on the device, can send the model, the insights, which are a fraction insights, to the cloud, and then combine them through federated learning in the cloud. And still, they've been trained on this high-frequency real-time sensor data, like 12 kilohertz of vibration data instead of like a 1 second average. So you actually get better insights and better granularity with way, way, way less data.
We often talk about deep learning and neural networks. We always talk about big data, but in the industry field, we do not have these big data. How much data do you need to train your model on the edge?
That's a very good question. And first of all, let me emphasize that we don't focus on deep learning, and that's for a few different reasons. I mean, everyone's predicting billions of connected devices, and very few of them will be able to afford a camera as a sensor. And deep learning is perfect if you're doing like LiDAR, radar, computer vision, that kind of stuff. But most products out of these billions of connected things will have regular traditional sensors, and that is typically time series data. And that's what we focus on to learn based on that. And deep learning, the computer vision, they will get output that we can use. For example, there's a human being going to the right and so forth. That can be valuable input to the more dynamic kind of machine learning we do, where we combine it with other sensor data. So that's our focus. And for that, this approach of doing individual training and then applying maybe a shallow neural network instead. And we also support linear regression and random forest. We're quite pragmatic about what is best to actually solve the case. Is really useful to do that.
What you deliver to your customer, is it a software tool? Is it an application? Is it a application with added hardware? Or can I use my edge device I have by my own? Or what is the product?
It's a software tool, spot on. It's 100% software. It's platform agnostic. We do all the development in C++ to make it as agnostic as possible, and then we generate a native C version, which is how we can scale down to very small devices. There's an API, so you can use Python and C# when you do the development of these models, and then you can use the same model and incorporate it into your CM implementation. There's a whole SDK with AutoML functionality that helps you with evaluating which algorithm might be the most suitable for the data set and so forth. It's a comprehensive tool to help expedite the implementation of edge machine learning. That's what we provide. And everyone runs the same runtime that you can compile. You actually get the source code that you compile into your edge firmware, edge product firmware. And then the model is separated, which means that the customer always owns the result that's being generated based on the data. And you can even hot swap it if you do federated learning and come to conclusions where you want to upload a new supermodel with new learning. So it's perfectly designed for this purpose of implementing a lot of different machine learning based functionality or features on board connected devices.
It sounds very interesting. My question is, the most difficult part for our industrial AI users or applications is the engineering to bring the software on the edge, to run the software on the edge. How difficult is that with your solution?
The thing is, at the end of the day, when you do the actual implementation, that's between 10 and 15 lines of code. But of course, that's based on doing the homework. And we are on a mission to make this as available and as simple as possible. Because you're spot on. I mean, the thing is, every company is not sitting with a data scientist. Some do, and they're pretty exhausted with all the different things you're going to do in all the different projects. But we are looking at the combination between three parties. You have the data scientists that have to help with understanding the analytics and the insights. Could be a machine learning engineer, someone who has a good insight into what it takes to draw insights from data, data-driven decisions. You have the engineer, which is very, very important, who possesses the domain expertise. Because, I mean, we can draw all kinds of insights using machine learning, but if we don't understand what it actually says, it's pretty useless. So someone who can really understand the problem and interpret the output that we get in terms of like change, deviation scores and anomaly detection, that kind of stuff. And then we have the software developer that needs to implement this, because this goes into firmware. So it's not like you do a PowerPoint production and just email it. It has to go through a proper validation and implementation. So 3 users, and with those 3 combined, if we can make it simple enough for them to use it standalone, then this can really happen. Then we can see a big increase in number of smart devices out there instead of just connected devices out there. And we come pretty far in making this simple. We're still pioneers in an emerging space that people are not that familiar with. So it's not just click and go, but we're getting there. We made significant progress as the global innovation leader in this space.
How long does it take with the initial learning when you install the software, and how long does the initial learning of the model takes time?
Oh yeah, I realized I didn't answer your question before about how much data we need and what it takes, and that's a highly relevant question. Unfortunately, the answer is pretty much how long is a string. It's very hard to say. It kind of comes back to case by case. But what we have seen is that we need surprisingly little data. We have one case where they were actually lacking sensors in total. And it was not possible to do any kind of intrusive implementation of sensors. And this is for a heat exchanger where you have fluids going in through different directions and meeting, and then you want to measure it. So we had to do the measurements outside. And the only measurement we could get was the temperature inbound, temperature outbound on 2 different streams, and the pressure. And with that alone, we could actually see how the effect and the performance of the heat exchangers started deteriorating, and use that to calculate the remaining time to service. How long does it take before you actually have to stop and do cleaning of the slates in the heat exchanger to make it run efficiently? So you need surprisingly little amount of input streams and still get some interesting results. There are cases where we have thousands of input streams, but that's the more the merrier in many cases, but you don't need a lot of input data. And the time it takes depends very much on what is the cycle. So if you have something that needs, in this case, like the cleaning, if it needs cleaning every 2nd week or every 4th week, then you need some repetitive patterns to actually learn. But if it takes 5 years, then the training time takes longer. But you can still find some insights on the way of getting there. But there are some characteristics that are favorable to machine learning, and there are some that are not. And this is something we're helping our customer with understanding. When can I expect a certain result, and what does it take to really train this? But still, independent, taking this approach of doing incremental learning on the device in operations would always be more efficient, because otherwise you're going to start collecting data, and you might need 2 years to get the seasonal changes and compare between year 1 and year 2. And by the time you get there in 2 years, you're going to have a new product, new configuration, new sensors, and it's going to be obsolete. So then you have to start all over again. So many companies actually fail because they try to collect all the data they need and then make decisions, and then it should be constant, while they operate in an ever-changing environment where they have to adjust to it. And then this kind of incremental approach where you do lifelong learning on the device for how the device is being used is very applicable.
Can you go a little bit deeper? What are you doing with the data on the software, especially from the cleaning use case?
Sure. What happens is that, first of all, the way we can do this on very constrained devices is that we do everything in memory. You reduce a lot of read and write. You don't do batch training, which is extremely resource demanding for a short period of time, but we do it for every instance of data. So we do streaming, analytics, we do incremental learning on the data. So we do everything in the process. So it starts with doing the pipelining that I mentioned to calculate a new sliding average or a lag and so forth. Then we do the inference. Then we do the training. Then we do the change and anomaly detection. Then we do sensitivity analysis. We can even do conformal prediction. So all of that can be done in memory, which is very efficient. So compared to just doing inference,
you need a very small time series database, right?
Yeah, and the thing is, it basically builds up over time. Since the pipeline is being updated, you don't really need the database, so to say, in particular. The pipeline is being updated on the fly. For the training, you typically need some kind of historical data, but we take what you have, which is in many cases, even with the large corporations that we work with, quite limited, and make the most out of it, the best out of it. Then we implement it, and then we refine it in operation. So you're right, you don't need a very extensive database to start with.
Do you use time series, you mentioned, right?
Yeah.
What kind of time series do you use?
So, I mean, in most cases, what we have seen is that a lot of the things we work with, we have been doing projects in industrial equipment, so it's very suitable for us. Things like pumps and electrical motors and compressors and that kind of stuff. Automotive, energy, building automation, so forth. What we have seen is that in most cases, they have pretty traditional sensors. It's a question of temperature on things that are rotating. It's a temperature of pressure in things that like pumps and so forth. It's a question of RPM. It's a question of voltage that goes into a process. That kind of input variables are very common input to our machine learning.
Do you use a special time series database there?
No, not really. Since we are doing the processing in memory, we don't.
Let's talk about two use cases. You mentioned the cleaning use case, but you have one special use cases in the medical industry. What you did there?
Yeah, the first one you mentioned, that is a typical maintenance case, and typically it boils down to two kinds of primary categories of use cases: maintenance and optimization. So the second one, it's for a ventilator, and that has been on everyone's mind due to the pandemic all of a sudden. And what we learned in the process is that every human breathes differently. So it's a unique how we breathe. Now, if you apply a ventilator that helps you breathe and you do it the same for everyone, that's not necessarily very healthy for your lungs, because you might apply too much pressure, too little pressure, etc. So since we've taken this approach to individual learning at the edge, we applied a solution where we actually learned the profile of a typical breathing stroke for the patient, the user, in less than 5 breathing strokes, and applied that to optimize the ventilator accordingly. So it actually replicated that to actually be a healthy approach to how you do ventilation. So very interesting case, and a typical one where it comes to learning and applying to optimize how you use it to run better.
I think it's very interesting because you have individual models all around the factory or the hospital where you use the ventilators, and then you can use this individual models to build a generic or a baseline model for the start when you have a new ventilator or when you have a new machine or when you do a optimization over the whole factory, right?
Yeah, and the thing is, more and more, if you look at the business side and the commercial side, more and more companies get reluctant to share data. We have customers that tell us that their customers say, no, you're not taking any data off the premises, which makes sense. That's sensitive data, it's production data. So the only place where you can learn is at the edge. And I think it makes a lot of sense when everything is starting to get smart. So the ball bearing manufacturer wants to provide intelligence. The motor manufacturer that uses the ball bearing wants to provide intelligence. The machine that uses the motor wants to provide intelligence. It makes much more sense that you feed that kind of intelligence locally. So the ball bearing tells the motor that tells the machine, because that's also the customer relationship you have, rather than the ball bearing extracting data to the cloud, processing it and sending it back to the motor manufacturer. It doesn't really make sense. So this kind of edge approach driven by the fact that you will not have access to all the data you want in the future, because customers get more and more educated and reluctant to share it, will drive a very big change in how we look at data management in the future.
What are your next steps with your company and with the technology?
Well, we're still a small company. We're pioneering this space, and we have a few steps to go before we have global domination. But I mean, our ambition is to provide a very easy to use, comprehensive toolkit for implementing smart features on your device, any kind of device. So a very broad approach to it. We now start to see that the market is catching up with us, and our way to reach the market is to go through partners, because as I said, we're a small company. The only way we can scale is that we work with those that build the solutions for the customer, the comprehensive solution, because we don't do hardware, we don't do sensors, we don't do cloud connectivity and everything else. So we work with systems integrators and that kind of partners who can build those so we can reach a much more global market. That's why we're putting a lot of emphasis right now to get the product out there at scale.
And there are a lot of famous ABB. You work with ABB, and can you name a little bit more? ABB and Siemens.
Absolutely.
Volvo.
Among our customers, a lot of prominent customers, and the reason is that we were aiming originally for the tier 2, because we thought that they were going to be faster, but they were typically suppliers to the tier 1s and we're getting instructions from those. So that's why we had to pursue customers like Volvo, ABB, Alfa Laval, Husqvarna, Siemens Energy, EHE. So different companies in different verticals, but very prominent customers, and very demanding customers, which is something we're thankful for. this stage.
So you are satisfied with the position as a second-tier supplier. You are happy with this situation?
Absolutely. I mean, the thing is that our main objective is that as many as possible can use this. And I'd be happy to take a position where it's econo inside and where someone else can actually provide that solution. I'm perfectly fine with that as long as we can reach as many users and devices as possible.
And is it a license model, or how do you sell it?
Yep, it is. This is software. It's all license model. You license the tools at an annual subscription, and then you pay a per copy fee when you start distributing it.
What about the next technology steps? What are the next steps in technology?
Well, you hit the nail on the head when you asked about federated learning before, because that is kind of the next step. Now, the customers have not been there. I mean, first they have to buy into the concept and the idea of doing individual learning, because that is the turnkey to doing the aggregated learning that we provide. But they're starting to really understand that, okay, this is really interesting. Now we can learn and automate on an individual basis, but we want to get that feedback loop where we can use this for generating better starting models or super models and for product development. So then we need federated learning. So they're starting to understand and request it. So that is probably the next big step in my opinion when it comes to product development.
I heard some rumors in the market that there's a big patent war on federated learning. Do you recognize that too?
We haven't been involved in that at this point in time. And I think what I have seen so far, and with some disclaimer, is that when it comes to this, it's kind of like when we talk about machine learning. It comes in very many different flavors. We have one way of approaching and how we use federated learning. In many cases, people or a lot of companies are using it more for the purpose of doing like distributed computing, using capacity in edge devices to do learning. So very different approaches. I hate that kind of, that's not the best use time to pursue different infringement and patent cases. So I hope that we can stay away from it, but we'll see.
You're based in Sweden, in the west of Sweden, at the west coast, correct?
Correct. In Varberg on the west coast.
Yeah. Because we had an episode with the guys from HMS. Maybe you know them.
Yeah, absolutely.
And they are also developing edge devices. Do you work together with the edge devices guys? Because that would be very interesting for them too, to add the technology to their device. Yeah,
absolutely. We know HMS for natural reasons. We know them quite well. It's not very far from here. I actually live probably a pretty good golf drive away from the CEO. But that is kind of the next step for us. That right now we have been focusing on reaching the end customers, helping them understand how they can really make use of this, the business case, the use case, and everything else, and prove it. And then that will generate demand. But of course, at the end of the day, just like we mentioned in Finian at the beginning of the episode, we will be implemented as a standard feature on chipsets, on hardware platforms, on edge devices, so you can activate it. Back to our ambition to make it as simple as possible. Being pre-installed, being pre-available, and being able to activate it is a way to help with that. So that is definitely part of our long-term strategy, to have technology partnerships like that.
Okay, so greetings to Stefan Dahlström.
Absolutely.
It was a pleasure to talk to you. I think it was at the beginning of this podcast, I think in the early 50s or something episode. It was a pleasure, John, for talking to you about your company and your product and your approach. I think it's very interesting. It was a pleasure to talk to you, and all the best to you, and greetings to Sweden.
Mutual. Thank you very much.